This is 11-1 solid geometry. With solid geometry, we're talking about prisms and pyramids. Prisms have two parallel bases. So if you look in the first two pictures, right here, the triangles are the bases in this one. They're parallel to each other. In a cylinder, these also have parallel bases of circles. For pyramids, they come to a point. Cones have the same thing. It has a circle base, but it comes to a point. And pyramids can have different shaped bases. So let's look at more of these. So for our prisms here, we have a triangular prism. So the parallel bases are triangles. Rectangular prism, parallel bases are rectangles. Pentagonal prism, the bases are pentagons. Hexagonal prism, the bases are hexagons. For the pyramids, it's the same idea. They all come to a point. So you can have a triangular base, a rectangular base, a pentagonal base, or a hexagonal base, but they all come to a point. When classifying figures, we might be asked specific details as well. So first of all, when I look at this base, this is a rectangular base, and I have a point here, so this would be a rectangular pyramid. This could possibly be a square at the bottom, but we would have to know that the four sides are congruent, and I don't know that. So then name the vertices. Well, the vertices are all where the lines meet, all the points at which the lines meet. So E is a vertex, D, C, B, A. They all have lines intersecting. The edges would be where the planes meet. So for instance, EC is an edge, ED is an edge, EA, BE, AB, AD, DC, BC. Those are all edges. And the bases, remember that we name a plane with 3 letters. So this base, this rectangle, could be called plane ADC. You can also name a rectangle with 4 letters. You could say rectangle A, B, C, D, or A, D, C, B. Once I start with one side, I'm naming the consecutive letter after that. Okay, here our bases are circles. So we have circle P and circle Q. There are no edges in a cylinder, and there are no vertices. And this shape is a cylinder. These are nets of 3D figures. So if you look at example A, I can tell that I have 2 triangles there that are going to be parallel bases from each other, and so this is a triangular prism. It's not going to come to a point. In example B, we have, looks like a square base, but I'm going to call it a rectangle because I'm not sure. So we have a rectangular base, and then I have all those triangles that are going to make that base come up to a point. So I know that that's going to be a pyramid. So that's going to be a rectangular pyramid. So example A, triangular prism. Example B, rectangular, possibly square, pyramid. A cross-section is defined as the intersection of a 3D figure and a plane. I like to think of it as if you were to take a knife and cut through the 3D figure, the shape that you would see when you when you separate the 2 pieces, the shape that you would see there is the cross-section. So if you take, in example A, if you take that triangular pyramid and you cut a slice through that in the direction shown, the base that you would be looking at that point when you lift that piece up and look at the bottom of it, that would be triangular shaped. So the cross-section is a triangle. If you take a cylinder and slice through that, according to the picture, we end up with a circle. Here we have a cube-shaped watermelon, and they're showing you that if you cut parallel to the base in example A, if you cut it parallel to the base, you would have a square, and to create a hexagon, you'd have to cut through the midpoints of all the edges. You cut through the midpoints of all the edges, your cross section would be a hexagon.